We know the trig values for special angles like 30 degrees, 45 degrees, 60 degrees, 90 degrees. But suppose we wanted to find the trig values for an angle like 15 degrees. Suppose we wanted to find the sine of 15 degrees. Well, we know absolutely nothing about 15 degrees because it's not one of our special angles that's on the unit circle. So knowing the values for the special angles and using the sum and difference identity formulas, we could easily find trig values for items like sine of 15 degrees without ever using a calculator. Look at this example. We are going to find the exact value for the sine of 105 degrees. Well, again, 105 degrees is not one of our special angles. So we use two of the special angles to add or either subtract to get 105 degrees. Well, if I add the sine of 45 degrees plus 60 degrees, that's the same as the sine of 105 degrees. 45 degrees plus 60 degrees equals 105. And I go up to my special formula, the sine of a plus b, since I'm adding two values here. Sine a plus b. My a will be 45 degrees, my b will be 60 degrees, and I take the formula, I'm going to duplicate the formula. Sine a plus b equals sine a cosine b plus cosine a sine b. Again, my a is 45 degrees and my b is 60 degrees. So I have the sine 45 degrees cosine 60 degrees plus cosine 45 degrees sine 60 degrees. I plug in those values. I have given you a unit circle here, but of course you should know these values by using the hand trick that we learned earlier this year. The sine of 45 degrees is radical 2 over 2 times the cosine of 60. Cosine of 60, 1/2. Plus cosine 45, radical 2 over 2 times the sine of 60, radical 3 over 2. And then we simplify. Radical 2 times 1 is radical 2. 2 times 2, 4. Radical 2 times radical 3 is radical 6. Again, 2 times 2 is 4. Therefore, the sine of 105 degrees is radical 2 plus radical 6 all over 4. Let's look at the unit circle. In case you forgot, remember when you go around the unit circle, you have the special angles and you have an ordered pair at each angle. You have an x value, you have an x value and you have a y value. The x is the cosine and the y is the sine. So, number 2, we want to find the cosine of negative 75 degrees. So this time, remember that we need to subtract to end up with negative 75. So I want you to pause the video and see if you can come up with two angles, special angles, that subtracts to give you negative 75, and try to find the cosine of negative 75 degrees. Pause and do that now. I hope you got the cosine of negative 75 degrees equals radical 6 minus radical 2 all over 4. Great job. Now, let's look at the tangent of negative 7 pi over 12. Whoa, what is negative 7 pi over 12? As always, we like to change radian measures to degrees so we all know what we are working with. So negative 7 pi over 12 is negative 7. For pi, we substitute in 180 divided by 12. So negative 7 pi over 12 is the same as the tangent of negative 105 degrees. The tangent of negative 105 degrees is the same as the tangent of 120 degrees minus 225 degrees. Well, if you remember, we cannot directly look at the unit circle and find tangent. Tangent is sine over cosine. So before we apply the formula, we need to do some side work. So we're going to come to the side and find the tangent of 120 degrees. So it's the sine of 120 degrees, radical 3 over 2, divided by the cosine of 120 degrees, negative 1/2. So we know when we divide fractions, we actually change it to multiply and flip the second fraction, do the reciprocal. So negative 2 over 1. So the tangent of 120 degrees simplifies to be negative radical 3. Now the tangent of 225 degrees. The sine is negative radical 2 over 2 divided by the cosine negative radical 2 over 2. No hard thinking here. The same thing divided by the same thing is 1. Great. Now we can apply the formula. We have tangent A minus B. So tan negative 105 degrees equals tan A minus tan B all over 1 plus tan A times tan B. Let's do our substitutions. A is 120 and B is 225. So we have tan 120 degrees minus tan 225 degrees over 1 minus tangent 120 degrees times the tangent of 225 degrees. The tangent of 120, negative radical 3, minus the tangent of 225, 1. All over 1 minus negative radical 3 times 1. Make sure you follow order of operations. So we need to multiply before we subtract. A negative times a negative is a, I'm sorry, that should be a plus. The formula is plus here. So we have 1 minus radical 3. Well, if you look at this expression, you will know that you cannot have a radical in your denominator. And when you have a radical in your denominator, you continue to simplify by rationalizing your denominator. So I will multiply the numerator and denominator by 1 plus radical 3. 1 plus radical 3. So as you can see, we will end up doing a FOIL method or double distribution in the numerator and the denominator. So in the numerator, once we multiply that out, denominator, first, outer, inner, and last. And simplify. Numerator. I have negative radical 3 minus radical 3. So negative 1 minus 1 is negative 2 radical 3. And then I have negative 3 minus 1, which is negative 4. In the denominator, positive radical 3 and negative radical 3 cancels, and 1 minus 3 is negative 2. And I can clean that up and have positive radical 3 plus 2. So the tangent of negative 7 pi over 12 is radical 3 plus 2. Great. All right, our next part of the notes, we are going to verify that each of the following is an identity. These are much easier identities than the identities that we had to prove last week. You'll like these much better. So we have sine of 90 degrees plus theta equals cosine theta. So we are going to prove that by using the sine of A plus B formula. So let me write that here. Sine A plus B equals sine A cosine B plus cosine A sine B. So the sine of 90 degrees plus theta would equal sine A, so that's sine 90 degrees cosine theta plus cosine of A, which is 90 degrees, and the sine of B, which is theta. So I need to simplify this to make sure it equals cosine theta. So does it equal cosine theta? Let's see. Sine of 90 is 1. We don't know what the cosine of theta is. Cosine of 90 is 0. And we don't know what the sine of theta is. Well, 0 times anything is 0. So I have 1 times cosine theta. Cosine theta equals cosine theta. Check. We proved it. So what formula would you use for number 5? I have cosine 270 degrees plus theta. You're right. You use the cosine of A plus B formula. So let's duplicate that formula. Cosine A, cosine B, minus sine A, sine B. Okay, pause the video and you try number 5 on your own. Okay, did you get it right? Great job. Now, number 6 is a double hitter. We have several things going on here. First, we have the sine of A minus B and plus the cosine of A minus B. So we're going to use 2 different formulas here. So again, I want you to pause the video and see if you can do this problem. Go for it. I knew you could do it. Very easy, right? So I hope that you proved it. I know that you did. If you have any additional questions, please see me. Thank you.